All right, we can have systems of inequalities just like we have had systems of equations. The definition of solving a system still holds. We have to find all the points to make all inequalities true. So let's look at the system of inequalities that's shown below. Determine if each of the following points is a solution or not a solution. So the first thing it's going to have you do is plug these points into the equations to the right. So 3, 8. I'm going to plug 3 in for x and 8 in for y and see if that's true for the first one. So 3 plus 8 is 11. It is more than 10. It's true. And for the second equation, is 8 more than or equal to 3 times 3 minus 5? So is 8 more than or equal to 9 minus 5? Is 8 more than or equal to 4? Yes, it is. So this one is a solution to this set of equations, or to this set of inequalities. For the next one, is 5 plus 9 more than 10? 14 is more than 10, so it's true. And the next one, is 9 more than or equal to 3 times 5 minus 5? So is 9 more than or equal to 15 minus 5? Is 9 more than or equal to 10? No, it is not. So no, that is not a solution to the set of inequalities. So letter C asks you to graph the solution to the set of the inequalities. So we're going to first graph the bottom equation because it's already in y equals mx plus b format, even though that's an inequality. And our b is our y-intercept, so we start at -5. And our slope is 3, so we go up 3 over 1. And since it has the or equal to, it's a solid line. If you use what we have done in the past on inequalities, we know that we look at the y-axis and we're looking at what's more than the line we created. So it's going to graph, we're going to shade this side of the graph. The other thing you can look at is the fact that you have already found a point that does work, and that's 3, 8. So 1, 2, 3, 4, 5, 6, 7, 8. So it should fall in the solution set. The next equation, x plus y is more than 10. It would help if I wrote y. And we need to solve for y, so we subtract x from each side. So y is more than -1x plus 10. So we're going to start at 10 on the y-axis. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Our slope is -1, so that means down 1 over 1. And since it does not have or equal to, then it's going to just stay a dotted line. Y is still more than that, so it's going to be up here. Notice how, again, it is where the 0.38 fell in between that. So the actual answer for this equation, or this system of equations, is just this section right here. On the grid shown below, graph the solution to the system of inequalities. State a point that lies in the solution set and one that does not. So, the first one, we're going to use red. We start at +2. The slope is down 3 over 2. Since it does not have an or equal to, it is a dotted line. Y is less than, so we are going to shade everything under the graph we just created on the y-axis. The next one, x is more than or equal to -2. We go to -2 on the x-axis, and remember when it's x equals, it's going to be a vertical line. It's a solid line because x is more than or equal to -2. Where x is more than -2 is on this side. So where it is double shaded is this triangle right here. So if we're looking at a point that's in the solution set, well, a point that's in the solution set is easily 0, 0. A point that's not in the solution set would be any other point that's outside the yellow. So if you pick 3, 3, that could be a point that's not in the solution set. So to determine if they are a solution to the set without graphing, you need to plug in x and y for each one, and they both have to be true. So in the first one, is negative 6 less than or equal to negative 4 times 3 plus 2? Is negative 6 less than or equal to negative 12 plus 2? Negative 6 is not less than or equal to negative 10, so this one does not work. Number 2 is 2 less than or equal to negative 4 times 0 plus 2. Is 2 less than or equal to 0 plus 2? It is. So now we use it in the second equation, because it has to be true for both. Is 2 more than 0 plus 7? It is not. So this one cannot work. Number 3. Is 10 less than or equal to negative 4 times negative 2 plus 2? Is 10 less than or equal to 8 plus 2? It is equal, so it works. And is 10 more than negative 2 over 2 plus 7? Is 10 more than negative 1 plus 7? It is, so this one has to be the one that works in both. Bye! So very often systems of inequalities will define proportions of the xy plane that can be visualized and manipulated. So consider the system of inequalities given below. Determine which, if any, of these points is a solution to the system. So we now have 3 pieces that we are going to use. So the very first thing I'm going to do is I'm going to graph it. So the first one I'm going to graph in yellow. So where y is more than or equal to negative 2.
Wyatt and Grace, your mom's with.
So if y is more than that, then we are going to do everything above that line. The next one, x is less than 4. So we go to 4. It is not a solid line. It's going to be a dotted line because it did not say or equal to. And x is less than that, so it is now this side of the box. You could, if you wanted to, shade everything on the left-hand side of that line, but we know that only one certain part of it gets to be the answer. And the last one is a linear equation, so we start at 0, and it goes up to over 1. It is going to be a solid line because it's or equal to. And on this part, y is less than. So the part that will be triple shaded is right here. So now we need to know, is the point negative 1, 4 part of the solution? What about 3, 1? 3, 1 is. So find the area, which we did that, and then D, why does the dashed line of one of the borders not make a difference in terms of the area that we found? Because the area that we found actually does include those points because they were shaded from the others.